Today we're going to learn to simplify what's called a rational expression and also multiply and divide rational expressions. So first I'm going to show you how to simplify a rational expression. A rational expression I consider to be a fraction with variables everywhere. Rational means can be written as a fraction. So a rational expression is going to be a fraction with variables in the numerator and the denominator. So if we look at number 1, we see x squared minus 8x minus 9 over x squared minus 1. So one thing that I don't want you to think you can do is simplify an x squared over an x squared like that. You can't do that because these minus signs here hold these expressions together. So even though the expression in the numerator has one term, it's all considered to be one factor. And even though the expression in the denominator has two terms, it's still considered to be one factor. So we can't separate factors by reducing them. So what we have to do in order to separate them is we have to factor. So the key word for this lesson is to factor. That's what we have to do. So we're going to factor our numerator into x squared minus 9 times, x minus 9 times x plus 1. And we're going to factor the denominator into x plus 1 times x minus 1. Now I have separated the numerator and the denominator into two factors. I have an x minus 9 times x plus 1 and an x plus 1 times x minus 1. So I have two factors in my numerator and two in my denominator. So now I can reduce any factor that appears in the numerator and the denominator, because what happens is I divide x plus 1 by x plus 1 and I get 1. So all I have left is x minus 9 times x minus 1. So that's how we simplify those expressions. Okay, so let's look at number 2. Number 2 has two fractions where everything is all one term. There's no plus and minus signs. So it's okay to say, all right, I've got y cubed over y to the 6 would be 1 over y cubed. It's okay to do that, but what I usually do, or it's also okay to say 4 over 20 is 1 over 5. That's definitely okay to do that. But since it's all one term, what I usually do is I usually multiply everything in the numerator together. So I get 4x cubed y to the 4th, because remember, when we multiply powers that have the same base, we add exponents. Also, I get 20 x to the 8th, y to the 6th. Now I'm going to reduce this fraction, which we already know how to do. So I'm going to reduce 4 over 20, which is 1 over 5. I'm going to reduce x cubed over x to the 8th, which would be x to the 5th in my denominator. And I also get y to the 4th over y to the 6th, which would be y squared in my denominator. And so since I don't have anything left in the numerator, I'm going to put a 1. Okay, so that's what we do when we only have one term in the numerator and the denominator. So let's look at number 3. Number 3, we definitely have more than one term. Excuse me. We have 3x squared minus 12. We also have 5x minus 10. We also have 2x plus 4. So once again, I said the key word here in this lesson is to factor. So we're going to remember that we're not going to reduce anything until we factor everything. So what I've got is two rational expressions that I want to multiply together. So before I multiply, I'm going to reduce. We remember from way back when we learned about fractions that we can multiply fractions by multiplying across the numerator and multiplying across the denominator. But we can also reduce before we multiply. So that's going to be the key here. It's always going to be a good idea to reduce before you multiply. But before you reduce, you want to factor. So step number 1, we're going to factor. Step number 2, we're going to reduce. And then step number 3, we'll multiply at the end. So factor, then reduce, then multiply. Okay, so I'm going to factor my numerator, 3, so I'm going to take out of 3 because that's our greatest common factor. And when I take out of 3, I have x squared minus 4 left. So I know that that can be factored again, so I'm going to change it to x plus 2 times x minus 2. In my denominator, I've got a 5x minus 10, so I'm going to factor out of 5, and I've got 5 times x minus 2. I've got a 1 in my other numerator, and in my other denominator, I've got 2x plus 4. I've got 2x plus 4, so I'm going to factor out that greatest common factor of 2. Okay, so I factored. The next step is to reduce. So remember, anything divided by itself is 1. So anything in the numerator and anything in the denominator that's the same, any factor that's the same, we're going to go ahead and reduce. So I see an x plus 2 divided by an x plus 2. I'm going to cross that out because that's 1. And x minus 2 divided by x minus 2, and that's 1 also. So I think I've reduced everything I can, so now I'm going to multiply across. Multiply across my numerator, multiply across my denominator. So I've got 3 times 1 in my numerator and 5 times 2 in my denominator. So the answer is 3/10. Okay, let's do another one. Okay, so number 4 is not talking about multiplying. Notice the expression, the operation says to divide. So we remember that when we divide fractions, we don't divide fractions, we multiply by the reciprocal. So the first thing I'm going to do is I'm going to rewrite it. 5x squared minus 20 over 25x squared. And I'm going to change it to multiplication, and I'm going to flip the second fraction. So I'm going to multiply by the reciprocal. So when you have to pay attention, because when we're dividing, we don't want to divide, we want to multiply by the reciprocal. So now I'm going to follow the steps. First thing I'm going to do is I'm going to factor. Number 1, factor. Number 2 is reduce. And then number 3, multiply across at the end. So I'm going to factor everything. So I'm going to take out a 5. So I've got 5x squared minus 20. So when I factor out the greatest common factor, I have x squared minus 4. So I'm going to put x plus 2 times x minus 2. And 25x squared is one term, so we don't factor one term. So I'm just going to leave it just like that. And then I'm going to go to the next fraction, and I'm going to say x squared plus 10x plus 24 is, let's see, it's going to be x plus 3, not 3 and 8, but not, 6 and 4. So it's going to be x plus 6 times x plus 4. And then in the denominator, I've got another trinomial, which is going to be x plus 4 times x plus 2. 4 times 2 is 8, and 4 plus 2 is 6. So we're good. All right, so I've factored everything, and now I'm going to reduce. So I see an x plus 2 in the numerator with another x plus 2 in the denominator. I see an x plus 4 in my numerator with an x plus 4 in my denominator. And I also see a 5 and a 25. So I'm going to reduce that. I'm going to say 5 over 25 is 1 over 5. Now I can reduce this. Let's go back. I can reduce this 25 here without this x squared because they are 2 different factors. 25 times x squared, 2 different factors. Notice there's no plus or minus sign in between them, which makes them different factors. If there was a plus or minus sign in between them, for instance, this x plus 2, x minus 2, excuse me, right at the top, that is one factor, x minus 2. There's a minus sign in between that, so we're not going to separate those. We can only reduce an x minus 2 with another x minus 2. So I'm going to reduce 5 over 25 and make it 1 over 5. And now I'm going to multiply across at the end. I've got x minus 2 times x plus 6 all over 5x squared. And there's no reason to multiply. If you multiplied, it wouldn't be incorrect. But if you don't multiply, it would also be correct. Okay, let's try one more. Okay, so we've got one more division problem. We've got x plus 7 divided by a fraction. So we don't want to divide by a fraction. I want to write x plus 7 over 1 because that makes it a fraction. And we want to multiply by the reciprocal. So I'm going to change it to multiplication, and I'm going to flip the second fraction. That's what we do when we divide fractions. We multiply by the reciprocal. Okay, so since I've done that now I'm ready to factor. Step number 1 is you're going to factor everything before you reduce. So I'm going to factor this numerator the trinomial in the numerator, and I'm going to make it x plus 3 times x plus 2. And I'm going to factor the denominator. I'm going to make it x plus 7 times x plus 2. Okay, and then I'm going to look to see what I can reduce. First we factor, then we reduce. We don't reduce anything until we have factored everything, remember. So I'm going to cross out. I have an x plus 7 here with another x plus 7. Remember, x plus 7 is one factor. The plus sign holds it together and makes it one factor. So we're not going to reduce an x plus 7 unless it's with another x plus 7. And an x plus 2 over x plus 2. So all I have left to do is multiply across. So I get x plus 3. And that's it.